Yes, I have my breadboard out. Okay. Now, push buttons are in here. Alright. I'm going to make a simple double pull, double throw switch machine thing that you'll see. Alright. Now, all single pull, double throw switches that I've seen. Oh, look, my diodes are in here. Use a button to change direction. So, let me get up here and I'll pull out a start button for right now. I should have pulled these parts out before I started the video, but oh well. Okay. Now I'm going to use red and green LEDs to show you which way the turnouts throw. This that'll help out. And I'm going to set up for a single first, and then I'm going to go for a double, and you'll see why you might need a setup that I want to set up. Alright, so negatives short. Okay. And yeah, breadboard makes this real easy, because then you can test things right away and know exactly what the heck's going on. Alright. I'm gonna place them in order than that. I don't even know if these batteries are any good. If not, I'll have to hook back up to the power supply for USB. Alright, so we're gonna find out if this works or not real quick. So for the red light, that would be there. I know nothing's going to work yet, but I still need to short out. I'll bring it from positive on over. Uh-oh. That ain't supposed to happen. Okay, what's going on there? What do I have? Oh, that's in there, right? Well, it's just a bad push button. Okay. It might just be... Yeah, it was the way I was bridging the contact. Okay. My mistake. Well, we know the battery's good. Alright. Whoop. Wrong hole. Okay. I need another lead. I need a longer lead than that. And give me that white wire. I must have did the same mistake twice. Alright, let me move these over so that way I can reach my big old fingers in there. Alright, so we see the red LED, and we push that button, we get the red LED. We push this button, we get the green LED, which is really bright. Alright, so that's reverse throw, that's normal throw. Alright, so let's add a second switch machine. Alright, and I'd like to do it up here. Okay. About the same columns. Alright, there we go with that. One really short. sorry, I know there's some really short jumpers in my kit, but I really don't bother messing with them too much. So yeah, that one will work. Okay. Let's put another black in there. And this pole. Throw it down here. Alright. So now we got two turnouts that we want to throw together. Like if we was doing a siding, you'd want them both to throw at the same time. Alright. But now let's say that you want to be able to back into a spot, like the 3 leads on a yard. Alright, now you're going to want a third button for a third root, so let's add another button in. Alright, got another short little jumper to it. Alright, we'll go for the bottom just like so. Alright, get some more leads out. Thought I had more already out, but oh yeah, they're just super long or super short. Need some mediums. Alright, so let's say that you want this last one to be regular on the one on the bottom, but you need a red on this one and a green on this one. Alright. Oh yeah, that's right, I gotta add that other jumper. Dumb. Alright. So you need a red on this one and a green on this one. But you hit that and you got turnouts going all sorts of crazy because all the lights are on. Well, that's no good for your turnout controls. So let's pull those all out because everything's shorting out. Alright. I think I pulled something I didn't want to pull. That's okay. Alright, so what we want is a red on this one and a green on this one on that button. We want 2 reds on this button and 2 greens on this button. So what we'll do is we'll wire it up to where when you push that first button, it'll be green on green. Alright. If I got that right. That's green on green. Now this one here we want red on red. So I hope that's right. Looks right. Now we know this much works just fine. It's when you get down here that it gets overly complicated. So what do we do about that? Well, let me find my paper again. I was all set up. Okay. Okay. had it. Well, this is the diode matrix for the layout. Way overly complicated for this situation. Alright, so we got roots A, B, and C. Alright, I'm just going to write them down. Alright. We'll just do this real quick. Alright. So we know that that all needs to be crossed. Well, how I do that is, alright, that red's 1A, and that black is 2A. So we know that that's 1A and 2A. So now I need a diode to go to, what is it? From I think I messed up. I've been doing too much research on this, and I'm probably a little overly tired. So, yeah, it only showed the one diode. Okay, so we take one diode. I'm going to go from the top portion of that switch on this side over to a blank spot over here, just to simplify it. Okay, so now I know that row will work. Or wait a minute, what was it? This one here needed to fire 1A. Yeah. 1A and 2B. So, wait a minute. Oh. Yeah, I put that one too far over. Alright. You get to here, you're automatically starting to see that you're having a problem. There's a way I have one turnout that wants to do a double. So, to fix that, we take that and stick it over here with this diode. No. Okay. I think I see what it is. Stuck the wrong wire over there. That wire goes to the diode side. This wire goes here. Now we got two greens. Whoop. Something ain't right. No. Okay. Two greens. Yeah, only the red. So I don't know if that's because no. Something is backfeeding, and I don't know why it's backfeeding. Well, that's showing all three too. Okay, but if I unplug that, that red one lights up. I see what it is. I believe I see what it is. Okay. Have to be not that one. This one. There we go. No, that doesn't switch back. Yeah. Like I said, I've been reading up, but oh, hey, that's right. Okay, that's what it was. But that wire's on the wrong spot now. So, this one here. Okay, well, that would be green. That's those two. Okay, so we're gonna switch this to root. Yeah, I messed up as I added a wire I shouldn't add it. Alright, so this one here being green, that's normal route that's going for the main line. That's coming off the main line going into the siding. Now we need one that goes to the red light. So pull the blue one back out of there. We'll hook that up to the red light. Ooh, wrong hole. Pretty sure that's what she said. Now we can test that. We know that's working right, that's working right, that's working right. So, how do I get this one to also light up a red here? Well, I need another diode. So, take another diode, poke it in that hole, run it over. And you remember, you want your silver part to always be going towards the negative. If I can get this to go down in that hole. So, yeah, your silver end is always pointing to negative. It's pointing to the ground. So, what did I say? We needed that one to show red and this one to show red. So, sneak in back here. See if I can get it. And there we go. There's no back feed, main line, first siding, second siding. And that's a diode matrix. There's one diode here and there's one diode here. They're both pointing away from that. And what they do is they stop the feed from coming backwards to mess up and light up both sides of the switch machine at the same time. So with this, you can go main, first track on a siding, both diverging. And that really simplifies things because I would need to have 4 buttons to do this. So instead of just pushing 1 to do it, I'd have to push 4. And that can get complicated with wiring too, because as you can see with this, there's 1, 2, 3, 4, 5 wires coming out. Now, and then your comment on that side. Now, I could simplify this more and save another wire or 2 if I wanted to. But for this board and this demonstration, that's all I'm doing. So there's a wire piece going to each switch machine. I could simplify it by a couple of ways to where there's a wire going to each side of the switch machines. Well, there's going to be 4 wires in the switch machine anyways. Just a lot of these are double connected. Like, and some of them don't have resistors on them or diodes on them at all. But this is how you have a diode matrix. Without the diodes, you wind up with, if I would press this button without the diode and everything hooked in here, it would all light up, which I can show you again. Actually, that's saying I didn't need a diode. Okay. Yeah, I didn't need a diode on that one. Sorry. Boink. No diode. Oh, that's why I needed a diode, because it bleeds back there. Okay. So which one needed the diode? Is it this one? Yeah. Okay. So yeah, you still need the diodes. I thought I had something messed up, but that's how it works. Now, I'm going to simplify it as much as I possibly can, but that's about as simple as a diode matrix gets. It is still a diode matrix. There's 2 diodes, 3 buttons, 2 turnouts. That means there's 4 positions. You got your normal, you got your normal diverging, and you got your diverging. And if I wouldn't have messed up, it would have been the same up top. But this is a great way to test to see how it actually works. Now, as you can see, you can short back a wire, which would cause exactly what I just showed you, where you got, there it is. The middle one we know is supposed to be green and red. The green up here and the red down here. But we got this red going again because it's got a backflow of electricity going to it. If I unplug it and put it back to the diode, we know that it's just fine. This one here. Alright, same way. Now if I unplug this and try to bypass the diode again, oh, well actually, no, because that's where it feeds back. So, as you can see, you would wind up with a backfeed. And that backfeed is not what we want. And that backfeed is eliminated by proper diode control. Diodes are pretty robust. These will run switch machines, and they're literally 1-watt diodes. They're good up to 50 volts. Diodes actually hold back massive amounts of current. I just bought a 50 pack of them because I'm going to need about somewhere between, well no, 100 pack of them. I'm going to need about 50 of them to do all that I'm planning on doing. And I'm hooking up under the table switch machines and everything else. And all the books that I have does not explain actually how to put this together, nor how to troubleshoot it. And this is basic, okay? So we start from start, and yeah, that's actually exactly how the world is mapped out. So we start from start, and then we start working our way down. Now I would say if you're going to be using this on actual AC current, you can skip the light bulbs the LEDs altogether and go directly for micro lamps. I still have a few from Radio Shack from years ago. These will help you so that way you can troubleshoot as you build, and that will work on the AC current. Now these are 12 volt on a wire base, which would be just fine. You can also go and still buy regular small incandescent bulbs such as nightlight bulbs and stuff like that that are still bulbs, or you can buy automotive type bulb. That's going to be using 12-14 watts. That's a heck of a lot more than what most things are going to produce. The only thing that I'm adding to this to make it a little easier for me is instead of trying to feed off of your normal power packs and everything else that don't deliver enough oomph to run a bunch of turnouts at once, is I am going to be getting a doorbell transformer. A doorbell transformer transforms not regular household current. So if you know how to basic wire 110, you can wire one of these up just by adding a 110 plug to the end. Which, remember, black is hot, white is cold, green is ground. Or depending on the codes in your area, that could be different. I know that from basically shocking the crap out of myself enough times to know. because I always thought black was cold until I grabbed a hold of a black wire. That's your basics on how this actually works. It's pretty cool little setup. I got me a breadboard for a change. I've never had one of these before, and this made working with electronics so much easier. Took a lot of the guesswork out, and none of this is permanent. I could pull it right apart and reconfigure it in some other way, so that way I could figure it out better. But yes, it's going to be trial and error to learn how to do a diode matrix. It's not hard, but it's not take one wire, hook up other wire, and done. So you literally got to play around, you got to plan ahead a little bit, and you got to work them through. Now, my plan is pretty ambitious, and hopefully I can get it all done. I know the under table switch machines are not going to be coming in as fast as I would like, because they are still between $10 and $20 a piece. But if I can buy 2 a month, 3 a month, I might be able to get by for a whole year and finish the layout. Maybe longer. But here we go. That is a proper diode matrix, and that's enough to work 3. And you just take this, scale it up to the next one, scale it up to the next one. Eventually I am going to have probably about 27 buttons. Yeah, 27 buttons on the next layout. Each one performs a different route. That will automatically line all my switch machines just by the push of a single button. That will be very nice. But at the same point in time, I'm scared half out of my mind on how in the world I'm going to do it. So follow up with me. I've got one 3x6 foot section of a 13 by 12 foot layout built. I've got to put profile boards on it, and then I'm going to be starting to lay track. So bear with me, I am getting back out to the layout eventually, and this is going to be a lengthy video, but I figured I should show you guys how to do a diode matrix, because nobody's taken the time to actually set one of these up. And it took me about 10 minutes to learn how to do this, from very, very vague descriptions. I would have never thought of this myself. It is actually very hard to get information about this. Everybody thinks you should automatically know how to wire this up, or automatically know from a weird schematic, which is that line on line that I couldn't figure out for the longest time, or how much voltage I would need or anything else. It literally took me sitting down and building one to realize, hey, this is simple, it's pretty straightforward, as long as you don't overthink it. I overthought this a lot, and I can tell you one thing. It's more basic than I thought it would be, but it works the same way. So y'all have a good one.